Dr. M. Suresh Gandhi is working as an assistant professor in the Department of Geology. He had also served as a faculty for the Center for Natural Hazards and Disaster Studies at University of Madras. He had completed his PhD in Geology, Micropaleontology at Tamil University, Tanjavur. He has specialized in marine micropaleontology and sedimentology. He has 12 years of teaching experience in geology, environmental geology, and natural hazards. He had received D.Sc. Young Scientist Award for the year 2004 to 2008. He is a member for Past Global Changes Switzerland and life member in Gondwana Geological Magazine Nagpur. He had presented more than 50 papers in national and international level seminars and conferences. He had published 40 papers in the reputed national and international journals. He had organized 10 national and international seminars. He has published 2 books on cyclones and heavy minerals. He had completed 7 major research projects funded by UGC, DST and DOD.
Welcome to UGC lecture series. Today I am going to take a class on disaster management part 3. Already I discussed about what is disaster and what are the different types of disasters and how the disasters occur in India. Now in this lecture I am going to deal with new directions in disaster management and particularly tsunami, flood, cyclones, landslides, mitigations measures. So, these are all the nodal agencies for disaster management. We have a lot of agencies, government, central government offices. For example, flood, we have a Ministry of Water Resource, CWC, and cyclones, Indian Meteorological Department, then earthquakes, Indian Meteorological Departments, and epidemics, Ministry of Health and Family Welfare, like that avian flu, chemical disasters, industrial disasters, rail accidents, air accidents, fire, nuclear accidents and also mine disasters. So, each disasters we have different nodal agencies and also we have a new directions for disaster management in India. National Disaster Management Authority, we called as NDMA. They have set up the Apex body for disaster management in India. Here our Prime Minister is a chairman. Disaster management authorities will set up at the state and district levels to be headed by the chief ministers and collectors, Jilla Parishad chairman respectively. Apart from this, other new directions to maintain or so mitigate the disasters, we have the National Disaster Management Fund will be administered by NMDA. So, they distribute the funds to states and district administrator for mitigations funds. NMDA also response funds will be administered by NMDA through National Executive Committee. States and districts will administrative state disaster response fund respectively. So, 8 battalions of National Disaster Response Force NDRF are being trained and deployed with CSSR and MFR equipments and tool in 8 strategic locations. National Disaster Management Policy and National Disaster Response Plan will also be drawn up. So far, what we learn with these disasters? So, we have to preparedness and also mitigations, that is beyond to yield more effective returns than distributing relief after the disasters. So, we have to create the culture of preparedness and preventions. So, evolve a code of conduct for all stakeholders. So, we go for future directions nowadays. So, living with risk. One is community based disaster risk management, that is inclusive, participatory, gender sensitivity, child friendly, eco friendly and disabled friendly disaster managements. Then is technology driven, but people owned. Then knowledge managements, that is documentation and dissemination of good practices. Then public private partnerships. Investments. So, investments in preparedness and preventions, generally we called mitigations, will yield sustainable results rather than spending money on relief after the disaster. So, we have to invest more on preparedness. So, most disasters are predictable, especially in their seasonality and the disaster prone areas which are vulnerable. Communities must be involved in disaster preparedness. So, whatever fund we do not spend after the disasters, we give more fund generate for preparedness pre-disasters, then only we have to mitigate the disaster. What are the new possibilities? Coming to the new possibilities, the national urban renewal missions for 70 cities so far done, unprecedented extreme weather conditions in few major metros and mega cities, and also 1 lakh rural knowledge centers. They need for special e-governance for informed decisions making in disaster prone areas before, during and after disasters. As I told earlier, earthquake is a major common disasters. How it is caused? I will show this diagram here. You can see this diagram, one plate that is called oceanic plate, another plate you have a continental plate. So, we call this continental crust, here you have a oceanic crust, below that you have a lithospheric plate, then you have a asthenospheric plate. The lithosphere plate is called upper part of the mantle, then the topmost is called crust. So, the crust and upper part of the mantle, that is a one plate. So, the continental crust or continental plate collides with another plate, for example oceanic crust. If both the plates are collide each other, the denser plate will go down fast. So, oceanic plate is denser than the continental plates. So, easily go down and it touches the mantle, there you have a heat generated area. So, more heat will be generated, automatically the magma is coming out via some intrusives called lavas, and it forms as a volcanoes and some island arcs and also mountain building activities. You can see this type of structures in Japan regions, lot of Japan islands. So, wherever this plate, oceanic plates and continental plates collide, you have get more number of volcanoes. So, what here told, the earth crust is a rocky layer of varying thickness ranging from a depth of about 10 kilometers under the sea to 65 kilometers under the continents. So, here the oceanic crust is very thin, whereas the continental crust is thick, we also called plates. Again, if you cross cut our earth, what you have to see? You have seen the crust, that is 0 to 100 kilometers thickness. After that you have a mantle layers up to 2900 kilometers. Then below that you have a core. Again core is two part, one is called outer core and another one is called inner core. So, outer core is liquid in nature, inner core is solid in nature. Suppose if you pass the seismic waves called primary waves, secondary waves, the primary waves can travel through all the medium with fast directions, whereas the secondary waves also travel through the medium, but it cannot penetrate into the liquid medium. So, it can divert. So, if we can based upon the seismic wave itself, we can easily find out the earth layers up to this crust, up to this is mantle, up to this is a core layer like that, and also with the help of density, temperature, velocity, we can easily layer our earth crust. So, what are the major cause? As I told earlier, two plates moving away from each other or two plates collide each other, what happen? One plate going down and another plate slide past each other. Once the plate goes down, automatically the heat will be generated due to the mantle convection current actions. The whatever material inside the earth will coming out and forming as a ridges. So, one side is slab pull, that means divergent, and another plate you have a convergent plates. Automatically two plates collide, you can get the earthquakes. Then stresses can be classified according to the type of movement along the plate boundaries. That means pulling away from each other, pushing against one another, sliding sideways relative to each other. So, these three factors is major cause for the earthquakes. According to the theory of elasticity, once the area of stress at plate boundaries release the energy by slipping or rupturing, we are simply called as fault. According to theory of elasticity, the crust is continuously stressed by the movement of tectonic plates. Once the stress will be more, automatically it will be elasticity, then finally it will be rupture. So, the rupture then occurs along the fault and the rocks rebounds under its own elastic stresses until the strain is relieved. The fault rupture generates vibrations. So, we call it as seismic. These are all different types of plate movements with examples. You can see the divergent plate, two plates moving opposite directions. Best example is Mid-Atlantic Ridge that splits nearly the entire Atlantic Ocean north to south, probably the best known and the most studied example of divergent plate boundary. So, if you see the map in Mid-Atlantic Ridge, every long ridge that is up to 2.5 centimeters per year, the spreading ridge spreading is or 25 kilometers in million years. That is one example. For another example, for convergent plates, suppose two plates collide each other, what happen? One plate, the denser plate goes down and lighter plates slides each other, automatically you can get a series of volcanoes, islands. Wherever the volcanoes forming, we called as ring of fire. Similarly, one place it is like that, then another place Himalayan mountains, two plates collide, one plate go down and one plate goes up, Himalayan mountain range also formed. Then third one is transformational fault boundary. Here the crust is neither produced nor destroyed as the plates slides horizontally past each other. The St. Andrews fault sliding through the Carrizo plain in Tembolar range east of city of San Luis Obispo. So, St. Andrews fault, California, that is the best example. Again, if you see this diagram, these are all the earthquake zone, high earthquake zone, low earthquake zone area like that. If you see the light color indicates the zone 4, that is the least active, very less earthquake, whereas slightly dark and heavy dark, that is the heaviest earthquake areas. That is called seismic zone areas. And also why the earthquake occurred already I told. Then depending upon the focus of the earthquake, we classified as shallow earthquake, medium earthquake and deep earthquake. So, based upon the focal depth, we also call focus. Suppose it occurred in the shallow, that is less than 60 kilometers, we call the shallow earthquake. It is 60 to 300 kilometers, we call medium earthquake. 300 to 700, we call the deep earthquake. So, shallow earthquake is more dangerous than the others. Again, within the Indian zone, you can see the fault lines. Already told lineations, wherever the cracks occurred in the earth surface, we called as lineations. That is called tectonic. Due to some tectonic movement, upliftment, one place going down, one place going up, you can see this type of upliftment. Wherever the upliftment is there, that is called a lineation point, and also the fracture zones. Within the fracture zones, we can get more number of earthquakes. So, this diagram shows the fault lines. So, depending upon the fault line, they classified as a thrust fault and also strike fault, dip fault, like that. Then again, this is the map. Now, the India classified into 5 zones, 5 to 6 zones. You can see here India is divided into 4 zones like 2, 3, 4 and 5, and zone 5 is the red color, you can see here. Zone 2 means the seismic is very less, disturbance of magnitude is 4.9. Zone 3 means up to 6.9, then zone 4 means magnitude 7.9. So, like that they have differentiate the earthquake prone zones. This diagram shows the how we have calculated the earthquake. So, effect of soil type on ground shaking. Suppose good soil conditions, you have get less earthquake. You can see the soil below the building, soft soils like silt, clay, like that soil means we have a weak soil conditions. Once the energy release, automatically the building will be collapsed. So, for that you have to construct the machinery buildings. So, this is also one type of prevention of earthquakes. So, we have to construct good condition between walls and foundations, also called stiff foundations. So, this is the good example for earthquake prone houses. Then what are the possible risk reduction measures? First is community preparedness, next one is planning, then we have to education, public educations, then construction of houses. Suppose if you take tsunami, this is also predictable. So, there is a two distinct types of tsunami warning. Now, we go for a break, I will continue later. Welcome back to my lecture. So, before the break we have noticed about how the earthquake occurred due to plate tectonics and other causes. Now, we are going to see about the possible risk reduction measures for other disasters. If you take tsunami, tsunami is a predictable one. Again it is how you have to predict with means with the help of community preparedness, planning, public educations and also engineering structures. So, foreign countries we have a international tsunami warning systems. Similarly, India also now launched and also regional warning systems. So, these are all the two distinct types of tsunami warning. What do you mean by tsunami warning systems? For example, you can see shortly after the tsunami, once tsunami started, they give a signals, the signal received, the whatever waves disturbed, we have a buoys, 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 they have plotted the buoys in the deep ocean areas. Wherever the tsunami waves and other tidal activities waves will be occurred, automatically the buoys receive the signals and transmit to the land areas. So, with the help of that buoys, that is a tsunami warning signals. With the help of signals, we can easily predict what time the earthquake occurred and what time it will be reached to the land areas. So, that is one method. For example, 1946 Pacific Tsunami Warning System was developed with operational center of the Pacific Tsunami Warning Center near Honolulu, Hawaii. Similarly, regional warning systems that can usually use seismic data about nearby earthquakes to determine if there is a possible local threat of the tsunami. Such systems are capable enough to provide warnings to the general public in less than 15 minutes. So, here in India, Survey of India, they have maintained the tide gauge networks along the coast of India. The gauges are located in the major ports. Once the tide gauge, they have also having radars. So, with the help of radars, they can easily predict how the waves coming fast to the coast. So, these are all the possible risk reduction. Apart from this, as I told earlier, plantation of mangroves, not only mangroves, construction of walls. Some coast you have a erosion, some coast you have a depositions, some coast already have higher elevations, that place you have no problem. Wherever the coast and land areas are very shallow, the tsunami water easily entered into the land areas. For example, if you take 2004 tsunami in Tamil Nadu, wherever the dune area and beach ridge areas, that areas are protected. Wherever without dune and only land areas with paddy fields, the water easily entered. So, that is also one reasons for tsunami water enter into the land regions. So, for that what they have to do, they have constructed the tsunami walls. So, for example, you can see here Japan has implemented an extensive program of building tsunami walls up to 4.5 meters high in front of coastal areas. So, like that site planning and land managements, as I already told, land use land planning maps, you have to prepare the land use land planning maps. You have to construct the house very close to the shore, that is not feasible. So, flood managements, flooding will result from tsunami, tsunami waves will flood the coastal areas, flood mitigation measures could be incorporated. So, whatever flood come, it will goes below the houses. See these construction buildings, this is the design solution to tsunami effect. So, it can withstand the tsunami. Like that, another example, if you see the cyclone, mostly cyclone occurs in tropical and temperature regions of the world, and India also one of the best cyclone warning systems in the world. For example, India Meteorological Department, IMD, that is the nodal department for wind detection, tracking and forecasting cyclones, and also they have tracked with the help of INSAT satellites, Indian satellites, IN satellite, INSAT satellite. Cyclone warning is disseminated by several means such as satellite based disaster warning systems, radio, televisions, telephone, fax, high priority telegrams, public announcements and bulletins in press. The warnings are disseminated to general public and also for fishing communities and also port authorities, commercial aviations and government machineries. Then what are the possible risk reduction measures for cyclones? Again, coastal belt plantations. So, as I told earlier, you have to plantation the mangroves, then prepare the hazard maps, then land use control, then engineering structures, then improving the vegetation covers. So, these are all preparing measures. Shelter, another thing is shelter with specific features to withstand the cyclones and floods, that is also, and also safe construction practices. You can see the construction at ground level, that is risk of inundation, more water easily entered in the house, and also large overhangs get lifted and broken. If you construct the house like this, automatically the top roof will be moved by the wind or cyclones or things. So, these are all safe methods. If natural elevation is not available, construction on the shift or artificial raised earth mounds, you have to construct your house slightly elevated one, and also large overhangs use ties, that is also safe. Like that, if you see the flood, flood is a state of high water level along the river channel or on the coast that leads to inundation of the land, which is not usually submerged. Floods may happen gradually and also may take hours or even happen suddenly without any warning due to breach in the embankment, spillover, heavy rains. So, again flash floods, that can be defined as floods. Mostly it occurs in 6 hours of the beginning of heavy rainfall. They are usually associated with cloud burst, storms, cyclones and requiring rapid localized warnings and immediate response to reduce the damage. Again this diagram shows the flood zones, mostly floods occurs in the northern part areas. This is the example how to prevent the flood. You have to construct the flood shelter. So, automatically water go inside that. What are the major causes of floods? Heavy rainfall, heavy siltation of the riverbed, blockage on the drains, landslides blocking the flow of the stream, construction of dams and reservoirs. These are all the major causes for the floods. Then how can you reduce the floods? Again mapping the flood prone areas, land use control maps, construction of engineering structures, decreasing the amount of rain runoff, flood diversions, like you have to divert the flood into levees, embankment dams, channel improvements. Then one more thing is drought. Drought is either absence or deficiency of rainfall from its normal pattern in a region for an extended period of time, leading to general suffering in the society. So, drought is basically caused by deficit rainfall, that is the meteorological phenomenon. So, it manifests into different spheres because of various vulnerability forces associated with them. Again, what are the vulnerability factors to drought? Why drought will occur? Low soil moisture, absence of irrigation, livestock without adequate fodder storage facilities, poor water management, deforestation, overgrazing, excessive groundwater draft, soil erosion, population growth, industrialization and global warming. Again, how to reduce the drought? You give public awareness and educate the peoples. Then drought monitoring system, we have to maintain the drought monitoring systems. Then water supply augmentations, then expansion of irrigations, then drought planning. Here you can see the diagram. So, rainwater harvesting. So, most this plan implemented in Tamil Nadu, and now it is running successful for rainwater harvesting managements. Like that, you can see this one place before drought mitigation efforts, then after the mitigations you can see the efforts. There are large number of paddy fields and constructions, everything is going on. Like that, one more example is landslides. All of you know landslides, nothing but the mass movements of the hill slopes. Here also they have falling, sliding, flowing or slowly or quickly from one place to another. The rock will be flow down. See this diagram. Landslide is a hilly terrain area. You can see these landslides in hilly terrain areas, how this occurred. Again, how can you prevent the landslide? You have to prevent using the hazard mapping, retaining wall and the plantation of trees and also engineered structures. So, these are all some preventions and mitigation measures. So, that we have to prepare whatever happen, first we have to prepare. We have to prepare from tornadoes, how to prepare for tornadoes, hurricanes, earthquakes, tsunamis, floods, fire, school violence, terrorist attacks, like that. So, in this lecture I would summary like what you have learned about different natural hazards and their possible risk reduction measures. Not only that, what are the causes of natural hazards. So, I would like to some few questions. Explain the causes of earthquakes, explain the different types of plate boundaries, explain the landslide risk evaluation, explain the effect of causes of tsunami. Thank you.